And welcome everybody to the Daily Space Weather Show. I'm your host Dan, aka Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. We've got a rapidly subsiding geomagnetic storm condition with a couple more on the way. Today we're starting the video out with some 24-hour imagery here from the Proba 2 mission, the SWAP 174 angstroms wavelength. And we do have a couple of new sunspots to talk about. We'll go over it and lots more today at the least busted name in news. Let's take a little closer look here. And we do have some setting active regions there in the northwest. There is a high likelihood of large solar flares up in that area. And let's briefly direct our attention to the northeast, where we have a new large sunspot that just rose. So far we only see one polarity umbra, so it is so far only an alpha class sunspot. We'll be monitoring that throughout the day. So there is the rising of that new sunspot group. It is a large umbra, a little larger than planet Earth, I believe. Also, you may see a new rapidly growing sunspot there in the southeast. Not on the limb, but to the southeast of that active sunspot in the south. So right up here, another new rather magnetically complex sunspot there. And this active region you see rising over the southeastern limb is only a plage. We don't see any dark umbrae indicating that it is at least yet a sunspot. And we'll take a very close look at that before the end of the video. In the meantime, don't forget to press the like button. Help us out via the algorithm if you're unwilling to become a member of the Smash team and do things like that, like get email alerts about our videos. Press the like button, and if you're new to the channel, congratulations on realizing it exists. We're frankly surprised. Press the subscribe button and get the world's most comprehensive daily space weather content and most detailed solar imagery that you'll find in the known universe. Again, thanks to our new subscribers. And thanks to the Smash team. More on the Smash team later in the video. Press the like button, press the share button, press the comment button. Leave us a derogatory comment, even if it's in jest. I might even get it. Remember, folks, sarcasm is hard to read when it comes to things like comments on social media sites. We also cover meteorology, which we'll do later in this video. Today's featured product is an old-timey term that we're trying to bring back, folks. You got to bring back old-timey terms. I mean, old-timey terms are just awesome. Did you know that imbecile is also an adjective? Yeah, imbecile. It's an adjective, not just a noun, which means the sentence "don't be an imbecile, imbecile" is not really redundant. It might sound redundant, but I'm using it as an adjective and a noun. So don't be an imbecile, imbecile, and visit the links below the video in the description and check out our awesome merch. 36 other products available there with 36 different designs. Besides don't be an imbecile, imbecile, bring back old-timey terms. Don't be an imbecile. You can also find links to the merch shop on the homepage at smashomash.com, which we launched back in February of 2019, and welcome to the Neo-Renaissance. We realized we needed our own server support for the channel, so visit us on the internet, the interwebs. Did you know that the internet is tubes? The internet is tubes, folks. The internet is tubes. The internet is tubes. Today's featured product on the Amazon shop, which you can also find on the homepage, right there. Just click on that or click the link below this video in the description to check out our spaceware collection. The drearier it gets, the brighter I dress. So today's featured product is, from Amazon, the Spaceware Collection Hawaiian shirt. It looks a lot like Scarface's boss's wall. It's not. It's a slightly different design, but many different Hawaiian shirts there. The drearier it gets, the brighter I dress, and it's still dreary here in Lehigh Valley, Pennsylvania. So wearing that brightly colored Hawaiian shirt today, Amazon.com/shop/Smash-O-Mash. Today's featured product from the Hemp Lucid shop is the stacks. Sleep stacks, stress stacks, and immune stacks, all $15 off. Save even more money by getting the full stack package. Links below the video in the description to our Hemp Lucid shop, so save some dough if you want to try out the sleep, stress, or immune stacks, or maybe all three. If you've never tried them before, they are capsules, by the way, not gummies. And let's get back to space. It's time to return to space. Because we've got some SDO imagery for you here. So again, we have a high likelihood of solar flares in the northwestern limb, also from this sunspot group, which is just moving past the Earth strike zone at the moment, and then a new sunspot formed just to its southeast as well. So we'll have at least 2 new named sunspot groups today. We'll also lose a bunch of sunspots which are setting in the northwest. Here's your colorized magnetogram. Again, you'll see that sunspot rapidly formed down there. It is already at least beta class. Looks like it's certainly beta gamma class. Not sure if it's delta or not. We'll show some high-res imagery of that at the end. And again, of course, there was a new sunspot that rose right there. So there is the colorized magnetogram. This depicts yesterday plus today, the SDO Browse Data feature. Let's step away from space for a quick moment to take a look at the world's most savory, tastiest sounding volcano. Stromboli has been producing some explosive activity there in the Aeolian Islands. Stromboli there, exploding. Great thermal webcam image. Suidose Jima, also exploding, flight level 060. It's producing a 6,000-foot plume of volcanic ash. Please do not pole vault the caldera. Mount Mayan, also erupting. Unknown volcanic ash cloud there over the Luzon Island, Philippines. 9,000-foot ash plume as Ibu explodes. That's Halmahera, Indonesia. Semeru exploding, flight level 150. It's a 15,000-foot ash plume over East Java. Dakono on Halmahera exploding, 7,000-foot ash plume there. Shishildin has intensified its activity there. Maybe a strong eruption to come from Shishildin, located in the Aleutian Islands. Popocatépetl exploding in central Mexico, flight level 200. Fuego exploding in Guatemala, flight level 160. Sangre exploding in Ecuador, flight level 240. Revenador, not sure if it's exploding or erupting in it at all, as volcanic ash is not observed in satellite. Sabancaya is exploding, flight level 240. Villarica is exploding, flight level who knows, over central Chile. That is where our volcano coverage ends and our earthquake coverage begins. Seismic activity has been low over the past 24 hours. Only a couple quakes of a 5 or greater magnitude, which are the ones that we will call out. Starting with this 5.0 in the Aleutian Islands there. That was at 15:01 Universal Time yesterday afternoon. It was also at depth, over 100 kilometers. 5.0 striking the Aleutians. So then a long time until the next 5+ magnitude quake, also at depth. On the opposite side of the world there, in the South Sandwich Islands region, it was a 5.0 at 4:12 Universal Time this morning. Depth 147.1 kilometers. And that's it, folks. Just 2 quakes of a 5 or greater magnitude. And let's break out some more imagery from SDO. Here's a great composite featuring 2 species of ionized iron there. That's the 211 and 171 angstroms, and 1 species of ionized helium, the 304 angstroms wavelength. Altogether, they're showing many different features, like filaments, coronal holes, active regions, sunspots, the extended corona, and even the lower quiet corona. We'll also show 304 angstroms by itself, the classic helium wavelength, and let's talk some additional stats. Actually, well, we'll show 171 angstroms also. I'll even zoom in on that because it's just spectacular. So that is September 24th and 25th to date from the Solar Dynamics Observatory. And let's talk stats. The 10.7 centimeter radio flux is at 173 solar flux units. It comes out of the upper chromosphere and lower corona, right about there, where my pointer is located. And there's the 1-year chart to put it in context. The black line is the 10.7 centimeter radio flux, also commonly referred to as the F107. It is the most proportional data that there is to sunspot number. High sunspot number equates to high radio flux, and vice versa. Space Weather Enthusiast dashboard here is expecting some additional geomagnetic unrest from a coronal mass ejection impact tomorrow, and there might be another one on the way as well, which we will analyze later in the video. At the moment, the geomagnetic storm conditions are subsiding, although we do have a very strong field, so if we see a shift in that field, geomagnetic storm conditions could come back rapidly, although I would not anticipate that to be a thing. So another CME to arrive tomorrow. Here is NOAA's Enlil spiral. As you can see in this imagery here, NOAA expecting a CME impact there early in the day tomorrow on September 26th. And here's NASA's forecast. NASA has not modeled that CME. So, not sure what's up with that. We'll check later and see if there's an update. But at the moment, NASA disagreeing there with NOAA's forecast. Anyway, here's Earth's magnetic moment from space for the past 4 hours. And again, we are just coming out of geomagnetic storm conditions, so there's a lot of plasma density around planet Earth. So yeah, that's the last 4 hours of Earth's magnetic moment from space. It depicts magnetohydrodynamic pressure, the units of which are nanopascals. Magnetohydrodynamic pressure. Lots of pressure around planet Earth. So here is our ground magnetic perturbations map. This is Earth's magnetic moment from the ground over North America. And again, we do have geomagnetic storm conditions that are subsiding kind of rapidly. It all has to do with the magnetic field orientation. That's what's been going on in the past 4 hours over North America. And let's show the global view as well. So a lot of aurora sightings happened as we had a rapid change in the magnetic field. Particle densities made it all the way up to 67 plus protons per cubic centimeter. We'll go over that here in a minute. So there are the last 4 hours of Earth's magnetic moment. And we did see some induction into the geoelectric fields there. So some power grid induction happening. The geoelectric field map is a great way to determine if aurora might be visible at your location. It doesn't only depend on latitude, it also depends on the status of the incoming space weather. Things like particle density, velocity, magnetic field strength, and magnetic field orientation. Also, the substrate beneath your feet matters. And again, KP index is currently at 3.33 there, so coming off of geomagnetic storm conditions, and we could go right back. We'll tell you why next. So again, we saw the particle densities get all the way up to 67 plus. And an extended signal there in the 30s. Also, we saw a significantly stronger magnetic field when it first struck. We saw a BT of 19, that's the total field strength, 19 nanotesla, with a vertical component of negative 16. So that BZ of negative 16 was enough to instantly cause geomagnetic storm conditions to show up. That negative BZ causes a lot of material to get pulled into the Earth system. So it creates a lot of electrical current. And that's a situation that causes geomagnetic storms and aurorae. So we saw a minor subsiding of the fields there. It still stayed at 19 nanotesla for the BT and negative 18. And there was another pulse here with strong magnetism, 17 nanotesla with negative 15 BZ. But then this morning, it rapidly shifted into positive territory. So while the field got stronger, as high as 34 nanotesla there, at least for a brief period, But then we had a positive BZ, which is more like a push than a pull on the Earth system, and so geomagnetic storm conditions subsided. Current conditions are still elevated here. The coronal coronal mass ejection still passing through. About 20 protons per cubic centimeter for the solar wind density. Solar wind speed here still slightly elevated from the baseline there, 439 kilometers per second. And let's move on to the GOES magnetometer, which showed a big downward spike here as a lot of plasma showed up. There you go. There's that geomagnetic storm condition showing up rapidly. So a big variation there in the GOES magnetometer. There's the 7-day graph to make it a little bit clearer, more clear what a geomagnetic storm looks like on the GOES magnetometers. Those GOES satellites are at about 23,000 miles of altitude, way out in the outer portion of the outer Van Allen belt. And they indeed had to, at least the GOES 16 had to do some maneuvering there. That's what the arc-jet moment is. The rocket thrusters create plasma that can mess with the magnetometer, so it's shown right there on the graph. Next, we're looking at the heliospheric current sheet and its polarity. And I think there may be one of two things going on here, folks. We're going to either see a delay in the South Pole current sheet. So Earth is currently in a North Pole current sheet depicted here in green. And we are expecting a possible delay for the South Pole current sheet to arrive. This sector boundary crossing might be delayed because of that sunspot in the northeast. So one of two things is going to happen. The South Pole current sheet is going to get delayed, or there's going to be a sunspot rising in the southeast. I'm leaning toward the second choice. I think there's a new sunspot rising behind that active region in the southeastern limb. Those are the facts. And do you like our new SNN colors? We've darkened them here for fall. Yeah, for fall. So we have that nice wine color there. Let us know what you think of that in the comments. Next, our line of sight field plot. Here the sun's B field depicted in blue, the B field being the field that goes through the magnet if this magnet is the sun. Photosphere magnetic fields in grayscale, north and south polar fields of the corona in green and red respectively. Speaking of the corona, let's talk coronal holes. Expect a continued uptick in coronal holes for the coming couple of years, as we're still like a year plus, possibly, from solar maximum. And we have had a major shortage of coronal holes throughout this cycle. So it's just basically a statistical probability, folks. We're just saying that, hey, you're going to see coronal holes straddling the equator more often because we haven't seen very many coronal holes straddling the equator throughout this solar cycle. We've had very low number of coronal hole-based geomagnetic storms, geomagnetic unrest conditions. Don't expect that to continue. It never does. These things have a tendency to even out. So let's take a look at coronal holes. Here is 211 angstroms from SDO. That is September 24th and 25th to date. And we'll shrink that down to show the full disk. So that is the coronal hole situation. And let's talk more facts from the Space Weather Station. Yes, sunspots are next. So we still do have a very large number of sunspots. At the moment, we have about 185 of them, according to the Royal Observatory of Belgium. And we do have a significant possibility for large solar flares. So multiple solar flare players here. A high probability of large flares up here in the northwestern limb, first of all. Also, this sunspot right here, this new one, has the kind of fields capable of producing large flares. And also, don't forget 3435. So multiple sunspots here capable of producing large flares. Not sure on this new sunspot in the northeast yet. It looks like it's only alpha class, but there could be additional umbrae hiding behind the solar limb at the time this video was produced. Let's take a look at sunspots from the perspective of SDO. So we'll zoom in a little bit closer here once again. Pardon my jostling. There you go. And that is still a lot of sunspots, folks. About 185 of them. You've also got the 171 angstroms plus colorized magnetogram. Good stuff. And before we look at any of that stuff, let's check one more thing out here. And there's the grayscale SDO magnetogram. It's a sunspot. It's me learning how to speak the English language. It's a sunspot fest, folks. It is a sunspot fest. And tell us how many other space weather forecasters are forecasting solar energetic particle events. We forecasted this one. I said it's overdue, and there's a magnetic channel enabling this to occur, and what do you know? A solar energetic particle event occurred. It's called understanding the physics, folks. So anyway, that minor SEP has subsided. There still is a chance for solar energetic particle events with the way things are currently configured. And by the way, a little quick blurb about our mission at smashomash.com/forum/mission. It's stated right in there that we want to do things like demonstrate cutting-edge proof of concept solutions to problems, publish scientific papers in a multidisciplinary fashion, and assist mankind by forwarding the study of predictive phenomenon. Yeah, predictive phenomenon. If you know how the data correlates, then you shall be able to forecast space weather. Next, looking at X-rays. Remember, folks, solar flares and coronal mass ejections are separate phenomena, so don't get them confused. The X-ray background level has now risen to about a C1.7. So, yeah, still quite a lot of activity here. Largest flare of the past 24 hours was only a C9.9. It's a pretty decent sized flare. And let's see where those were coming from. This is another SDO all day yesterday and today to date. So I would suspect that this new sunspot up here in the northeast is not alpha class because we see activity there. So it's probably at least beta gamma class. We've got multiple magnetically complex sunspots here on the Earth-facing portion of the solar disk. Likelihood of large solar flares remains very high. Likelihood of solar energetic particle events remains very high. Those are just facts. And here's 131 angstroms as well. The other of the two best wavelengths through which to view solar flares from the Solar Dynamics Observatory. Now let's move on to talk about what's going on overhead. And to that end, here's a star chart from skyandtelescope.org. This is what's happening over Lehigh Valley, PA. Jupiter's setting. Venus, Mercury, the Sun, and Mars are chasing across the ecliptic. If you want to make your own star chart, just put in your location there at skyandtelescope.org's online planetarium. I like the way you can zoom in on certain areas here. We do have some interesting cosmology stories for you today in just a minute. First, the solar system forecast. Here's where things are today. We'll advance this 1 week. That's where things will be in a week. And OSIRIS-REx is now on its way to the asteroid Apophis, having dropped off its payload here, successfully touched down with its payload from the asteroid Bennu. So the largest sample ever returned from an asteroid just got dropped off yesterday around 11 o'clock Eastern Time in the Utah desert. Exciting stuff. And here's today's astronomy photo of the day. It's the Hummingbird Galaxy in multiple wavelengths there. We're looking at I believe that is X-ray as well as infrared. Or it might just be ultraviolet and infrared. The Hummingbird Galaxy. So very dense dust lanes there in the foreground. And a series of bright blue stars there, high X-ray producing stars all around the coma of this. Quite an interesting galactic merger going on, and the theory is that it got too close to this elliptical galaxy down here, and it is in the process of obeying gravitational fields. Well, that's the astronomy photo of the day, the Hummingbird Galaxy. Some people see a dolphin, I don't know. apod.nasa.gov if you want to check it out on your own. Fantastic dust lanes there around what was perhaps formerly a spiral galaxy. And let's talk about naming conventions. So one of my favorite galaxies is 3C405, a catchy name, right? And of course, the names of astronomical objects, whether they're galaxies or pulsars, there's always a purpose to them. Usually it has to do with what catalog they're in. So in other words, M31, the Andromeda Galaxy, it's M31 because Messier cataloged it. He was looking at these nebulous objects that they didn't realize back then were galaxies. And anyway, Cygnus A is one of my favorite galaxies. It's actually the most powerful radio source in the sky. Second only to the sun, that is. Despite being over 500 million light years estimated distance. Now, these are the X-ray outputs from Cygnus A. If you view that on the Neil Gehrels Swift-Bat X-ray Observatory, you just type in 3C405, click on entry number 922 there, the X-ray outputs, and if you want to look at it in different frequencies, click on Simbad, and then you can get yourself to the Aladdin images. And anyway, Cygnus A is a galaxy that has this central core, and then it has these massive radio lobes. So it has like 2 radio lobes that are farther away from the galaxy than the diameter of the galaxy itself. That wavelength, by the way, that is the, what is that? I have no idea what that is. Oh, that's the Herschel Spire 350 micron, which is, I think that is, that's infrared spectra. Cygnus A, the brightest radio source in the entire sky, besides the sun, that is. And the reason I'm bringing it up is because naming conventions. So here's a great article about naming conventions from SciTech Daily. SciTechDaily.com. Hubble Space Telescope captures galaxy SDSSJ103512.07 plus 4614112.2. Why is it called that? Because the name of the galaxy is telling you where it's located. So this one is in the constellation Ursa Major, and that's a reference to the celestial equator, which is halfway in between the 2 celestial poles. And I won't get into that, but if you want to read about the naming conventions, there's a great article on SciTech Daily about the naming conventions of galaxies. That's sort of my cosmology blurb for the day. And for you folks who haven't been viewing the channel for a long time, the reason that I do these videos is because I almost majored in cosmology in the mid-90s, and I realized that becoming a pro athlete was something that had a time limit on it, so I had to get out of college and go do that, and now I'm back, because who knew there would be a huge hole in heliophysics, which represents a huge hole in cosmology? Well, I did in the mid-1990s, and that's part of the reason I didn't major in cosmology, because college astronomy featured like about a paragraph about how the sun behaves the way it does. I thought there'd be an entire month dedicated just to heliophysics, but there wasn't at all. And yeah, so anyway, that's why I'm back. And in science, we often end up with answers to questions not asked, which is how I came up with my Krapf hypothesis to explain the solar sunspot cycles. You want to hear all about it? Become a gold member of the SMASH team. You can find out about it before we even submit it for peer review and publishing. Anyway, it's time to move on to coronal mass ejections. because we've got some coronal mass ejections here from yesterday. And I think there may be an additional earthly directed one to arrive on the 27th late day or perhaps early day on the 28th. So this is a fairly stealthy one here. And in the 102 frames from yesterday, you'll be able to see it, but it might not look like it's earthly directed. So this one is a tough one. And we're going to show you why here in a minute. That's 102 frames from yesterday, September 24th. And here are an additional 43 frames from today, September 25th. So let's take a look at some more imagery here. So here's Soho Lascaux C2 and C3. And around midday yesterday, some events started to transpire. A big CME in the northwest, and then a smaller CME in the northwest, and then a smaller CME sort of out of the west. And that last one out of the west, I believe, is earthly directed. So we pause this right here because it's multiple events. So let's first take a look at the C2. We're going to bring this back. So that big CME is already on its way out there. That's not the concern. The second one here, that is not earthly directed either, we don't think. However, this next one, this one right here, which is starting to come out from behind the coronagraph around 1830, that one does have a partial halo. So that is another earthly directed CME. It is not on the far side. Sometime around 1800, that started to emerge from behind the disk. So right there you can see that. It looks pretty minor. However, when a CME is headed directly toward the coronagraph, a major CME can look minor as it can be obscured until it's very diffuse on its way out of the corona. So we're going to show some additional imagery here from stereo A and stereo B. Unfortunately, we don't have most of the data on that. Oh, not too bad. All right, it's actually there. So that's another Earth-directed CME, folks. Expect that one to arrive late in the day on the 27th or early in the day on the 28th, sometime around then. Late day 27th, I would suspect. Right there is that third event. Perhaps a little bit on the stealthy side, but we did see a bit of a halo from it. So we're going to show you here next why we think that is earthly directed. Bear with me while I bring up our custom coronagraphs. Actually, let's take a look at some SDO imagery first. All right, so let's attempt to show the origin of that CME. Now, we did see it come out of the west, so that gives us some idea of where it might have come from. And it was sometime before 1800, so probably sometime around 1500 or later. We do see some plasma motions down here. So I suspect that is where it came from. We're going to see if we see a filament eruption or not there, but it looks like that is where that actually came from. So this is a thing that can happen regularly. You see a CME from the east side of the sun ending up on the west side. The other possibility is that it's on the far side, but it looks like some plasma motions to me there. So I believe that is another Earth-directed CME. And here comes some custom coronagraphs. So this is a 24-hour video. So there's that first event, there's a second event, and then there's a third event in succession. Those are three separate CMEs from different locations on the sun. The first two were really on the northwestern limb. The third one, I believe it was in the southeastern. Close to center disk, though, which is how you get a halo and how you get it coming out in all kinds of irregular fashions. So here's a little closer view. You see 1, 2, and 3. Here it is again, 1 and 2 and 3. Number 3 is the one that looks like it has an Earth-directed component. Here's an even closer view. That is, by the way, the Proba 2 swap 174 angstroms wavelength once again. There's 1, there's 2, and there's 3. So anyway, expect another CME to arrive on the 27th. So let's take a look at filaments here, as we might be able to see some additional information on that. There is the ground-based solar observatory at El Teide, Spain. And we're looking for a filament that goes away from down here. And let's actually stop that. It would have been sometime after midday yesterday. Let's see if we see anything going on down there. We'll just slowly advance this. It could have come from here, it could have come from up here, or it could have come from down here. But I suspect that is earthly directed because of the way it looked on the coronagraph. That's my best guess. If I had to guess, and I don't, that would be my guess. Arrival late in the day on the 27th. Here's the grayscale imagery also. We've been naming solar filaments after living people, and frankly, I don't remember who they're named after at this point. There is insufficient participation for me to care. So join us over on Twitter. And by the way, today we get to talk about something that we don't want to talk about at all, but we have to because of the nature of how these videos, because of the media on which these videos are portrayed. So man, look at the number of filaments, by the way. Let me just stop this. Huge filament over here. This one's the Russell brand. I remember that. So that's 1, 2, 3, 4, 5. I'm going to call this 1, 6, 7, 8, 9, 10, 11, 12, 13, 14, at least 16, make it 17, make it 18 filaments on the Earth-facing portion of the solar disk. That is a lot of filaments. There is a lot of plasma pointed right at Earth. Again, if you want to name filaments after living people, do it over on Twitter, not in the YouTube comments section. We just won't accept that. You got to be on Twitter, and you have to be able to comment on Twitter, which means you need to have an account. So yeah, I mean x.com/smashomash. And we did feature a bunch of auroral imagery. That's the only one I'm going to show you because people need credit for their work. And of course, you'll find lots of information from last night about censorship. Yeah, about censorship. So here's the part where I don't want to talk about this in any way, but I'm going to talk about it anyway. Here it is. If you're not familiar with Missouri v. Biden, guess what? The government has been barred from contacting social media organizations to try to limit the legally protected speech of Americans. Yeah. So there's an injunction that occurred on back in July, I think it was. Anyway, read the article if you're not familiar with Missouri v. Biden. Let's just say the implications are rather significant. Certain social media organizations who are the tools of this censorship industrial complex were utilized by the government to shut down the speech of people like you. Now, some people like me might have experienced massive failures in our businesses who rely on social media in order to get videos like this onto people's screens. As you know, we figured we could say whatever we wanted because it's the United States. Anyway, the implications on the tech companies, namely Alphabet, Apple, Meta, and Twitter, are very severe because these organizations were the tools by which protected legal speech was suppressed at the behest of the executive branch of government. So you could imagine how that could create some problems, right? So I just thought I'd bring it up. If you're not familiar with Missouri v. Biden, go have a read. There's a great wiki article about it. And of course, this isn't completely done yet, but on September 8th, the Fifth Federal Circuit Court ruled against the federal government, found that some of the communications between the federal government and social media companies try to fight alleged COVID-19 misinformation, quote, coerced or significantly encouraged social media platforms to moderate content which violated the First Amendment. Yeah, it's a problem. So I just figured I'd bring it up since it's commonly not known by anybody. I don't know. So there are some facts. Very controversial facts. Here are the past couple of hours of what's going on the closest star here from the GOES 16 SUVI, which we are streaming on the Twitch channel, by the way. We've got some great crown prominence activity up there. A bit of a crown prominence hanging out there in the North Polar region. Gotta have it. And again, folks, a very high likelihood of large solar flares in several different active regions. That is the past about 2.5 hours, and let's blast through our bonus feature segment. We do have some significant surface charging hazards here for satellites at the moment. That is when electrons build up on the outside of satellites and can cause some communications breakdowns. Those low energy electrons, they build up on the surfaces of satellites, and they won't damage the satellites, but they might interfere with the communications. So there is where your surface charging hazards are at the moment. Moving into the Central Pacific as we produce the video. GOES electron flux here has cratered exactly as forecast. Now keep in mind that is an erroneous reading because the ionosphere puffs up when geomagnetic storms strike. So really the GOES 16 and GOES 18, they're measuring the electron flux at a lower level than where the ionosphere is actually located. They measure the electron flux at the F layer of the ionosphere using radiography from their very high geosynchronous orbits that I described earlier. They're at like 23,000 miles of altitude, and they're measuring the electron flux at about 300 kilometers of altitude. Here's the one-year graph of the electron flux. Those are the relativistic electrons there, as reported by Solon.info. And here's the forecast model expecting this dip. No real surprise there. And I would tend to agree with those forecasts represented by the green boxes. That's NOAA's forecast for the relativistic electrons. We also like to show the layer where it's measured, the F layer of the ionosphere. Again, it's at 300 kilometers of altitude. Here's the vibrational frequency up there. And you can expect to see lots of low-frequency anomalies, a common feature of geomagnetic storm conditions. If you're not familiar with this map, don't worry. We show the anomalygram as well. Here it is. There's anomaly in megahertz from a 30-day median. And by the way, the time around the equinox is the most geomagnetically active time because of the Russell-McFerrin effect, which involves the acceleration of relativistic electrons in the outer Van Allen belts. It's caused by the angle of attack from incoming solar particles. Earth's magnetic field is more perpendicular to those particles around the equinoxes, and it creates more Bremsstrahlung. Yeah, Bremsstrahlung, the braking radiation as those particles obey Earth's magnetic field lines. Anyway, here's the latest image of the ionosphere. There is 1345 universal time ionogram and 1345 universal time anomalygram. And it is looking like it wasn't really that perturbed by that geomagnetic storm condition, again, because the vertical component of the magnetic field went deeply into positive territory. So we saw the strongest fields in a long time at 33 nanotesla. But that was accompanied by a strong positive BZ. So that did not help to induce current into the earthly system. Speaking of the earthly system, here's the total electron content next, which will show you the most likely places for GPS errors. Feel free to pause the video on this frame if you're not familiar with things like the altitude of the International Space Station, or your GPS satellites, or perhaps the outer Van Allen belt. That's where those things are located. Here is the total electron content, literally a count of free electrons from ground level to about 12,500 miles of altitude, where your GPS satellite is located, in its lower geosynchronous orbit, much lower than the GOES. That is the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere worth of free electrons there. And we do see some anomalies here. We'll show North America some significant anomalies here. This is the anomaly from the 10-day average over North America. Some big-time high electron count anomalies there over places like the northwestern U.S., large portions of north-central Canada, parts of Mexico and Central America. So those would be like unexpected GPS errors. Some very high electron contents there. So no real surprise there, as geomagnetic storm conditions have a tendency to create some anomalies. We'll close out the space weather section of this video before we switch to meteorology by looking at the latest intensitygram and the latest magnetogram. First, let's look at this new sunspot. There it is. I only see one umbra, so it is still an alpha class sunspot. I suspect there will be more umbra here rising in the next couple of hours. These are the groups most likely to produce large flares. That one especially. That is a classic beta gamma delta class configuration. And this new sunspot also beta gamma delta class. So that is good news if you're hoping for solar flares. If you're frightened of solar flares, sorry, that's bad news for you. So multiple regions there with the possibility of seeing large solar flare events. By the way, if you enjoy the content, consider becoming a member of the Smash team. There's a bronze level, which costs $0 a month. There's also a silver level, which is $2.99 a month. Support the channel that way, or perhaps the gold level, which is $9.99 a month. The best value is the gold annual paid-up subscription, as it does include complimentary merch. So many ways to support the channel. Visit the links in the description to do that. These videos are brought to you in part by the Smash team and in part at massive personal risk and expense by Smash staff and I, smashomash.com/Smash team. We launched it to replace Patreon, not because we had beef with Patreon, just because it is superior. Our own custom subscription services site with our own financials and so forth. Smashomash.com/Smash team. And let's move to meteorology. We're going wave chasing to start things out. Yeah, wave chasing. The biggest waves in the world here are in the northeastern Pacific, about 30 footers, which means the world has largely calm seas at the moment. So the other major lows are located in the Southern Ocean, but they are not as low as that one in the northeastern Pacific. So that's depicting surface winds and wave height. Some big waves right now around Western Canada. Anyway, let's show the world's air masses. We'll start out with surface winds of the east. There you go. Shout out to our viewers from Munda. And if you're viewing from this area, please press the share button, as we have extremely low number of viewers from that part of the world. Only the world's most popular portion, the most highly populated portion of the planet, no big deal. And by the way, YouTube has like 20 billion monthly viewers, so it's pretty serious. There are the jet streams of the eastern world. Here are the jet streams of the central world. The 250 hectopascal winds. Surface winds depicted here for Europe, Africa, and the Middle East. And there are the western world's surface winds. That strong low there off the coast of Vancouver. And this tropical low here is probably getting entrained with a bunch of dust. Let's show it here. First, the jet streams. And this low is about to get pummeled. Watch. Particulates, the dew-X, and yeah, a bunch of dense Saharan dust is getting all entrained in that. That is not going to be good for those hoping that turns into a hurricane. that reduces the likelihood of it becoming a hurricane significantly. Let's take a look at sea surface temperatures next. Why not? We're doing meteorology. I'll make the video as long as I want. It doesn't seem to affect our views. They just go up and down on YouTube randomly. So anyway, here are the world's sea surface temperatures. This also depicts currents. Great view of currents here, by the way. If you're frightened of the AMOC shutting down, you may want to view this because you can see clearly the Gulf Stream is looking just fine. You can even see some backflow here. People are very spooked that the Gulf Stream's going to shut down and Europe's going to freeze and the whole northern hemisphere is going to turn into a snowball Earth scenario and so on. I just don't see it. Everything looks totally normal there. But anyway, here are the world's sea surface temperatures. I just figured I'd briefly bring this up. Not sea surface temperature anomaly, just raw sea surface temperature. And it looks just fine to me. If that map spooks you, we apologize. Here come clouds and fog for the Western world. That's our NASA GOES Interactive Weather Satellite Shortwave Radiation Map. 3.9 micrometer infrared radiation. And here's your weather.gov map. We've got some frost advisories there in northern Maine. Not sure what the rest of those weather alerts are. Let's scroll down and show the key. So there are your weather warnings. If your location is illuminated on the map, please head to weather.gov and get your weather alerts. Those are too many counties for us to cover. And let's do some forecasts here. And these GFS forecasts are courtesy of Tropical Tidbits. Yeah, tropicaltidbits.com. Check it out if you haven't done so. Tropical Tidbits. We show the content daily on the channel. And here's your GFS 72-hour pressure and precipitation forecast. As more pulses of rain expected to come to Pennsylvania, thanks a lot. And the Pacific Northwest is a little bit more moist than it would prefer. Also, Florida getting consistent rain. Anyway, there's the forecast. Read them and weep. Here is the total accumulated precipitation forecast. Same model, the GFS 72-hour. Precipitation totals shown here in inches. And look at the insane amount of rain coming to Washington there. 6 inches. 6 inches of rain there coming to Washington. Also, very heavy rains for Northern California and Southern Oregon. The coastal regions. Dag! That's berserk! Berserk, I tell you! Next temperature anomaly forecast, the same GFS 72-hour forecast there. This is in degrees Celsius. So that might look a little less extreme there, but keep in mind 16 degrees Celsius is a lot of degrees Fahrenheit. I don't know exactly what the conversion factor is. The 72-hour GFS temperature anomaly forecast. And for those of you worried about it being cold, and for those of you worried about it being hot, all of you can say, "Oh my God, no, we're going to freeze, we're going to burn, we're going to have to have a coat on, we're going to have to be in air conditioning, oh no!" Now that I got that out of my system, how about the NASA GOES Lightning Mapper? Texas has been the U.S. lightning capital for the past about 10 hours. Also, Cuba had some severe lightning. Look at that line, folks. It's shifting. The darkness is shifting to the northern hemisphere, folks. Happy spring to you folks in the southern hemisphere. Happy fall to all of you folks who drink the horrendous pumpkin spice beverages. Oh my God, how do you do it, folks? How do you drink that pumpkin spice crap? It's ew. Ew. Pumpkin spice. By the way, pumpkin has no flavor. Pumpkin spice is simply sugar, nutmeg, and cinnamon mixed together. That's all pumpkin spice is. Pumpkin spice, not a thing. Pumpkins are tasteless. What makes them cool is that they are a neutral palate on which to cook things. Pumpkin spice, it's sugar, cinnamon, and nutmeg. Next! The U.S. Doppler radar. If that was too controversial for you, folks, just unsubscribe from the channel. If we're offending you with our views on pumpkin spice, then you can shove it. Just press unsubscribe and do not catch the world's most comprehensive daily space weather videos and most detailed imagery of the sun. Here's our clouds and fog map. Shortwave radiation, infrared radiation emitted by those clouds and fog over the U.S. Yeah, clouds and fog, they emit infrared radiation, otherwise known as heat. And here is the water vapor map. So that'll clear things up as an atmospheric river descends upon the Pacific Northwest. Anyway, there it is, turning into an atmospheric waterfall up there. Dag! That is bonkers! And here is the clouds and fog map. And here is the water vapor map. Hopefully that clears things up. CMEs, additional CMEs on the way. Coronal mass ejections, likelihood of large solar flares, likelihood of solar energetic particle events. Facts, very controversial. Make sure you deboost the content. Big tech organizations, that's going to be very helpful. That's going to totally accomplish your corporate mission. Anyway, in the meantime, see ya. Hopefully you haven't created too much liability for yourself by understanding basic facts about things. And we'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. I'm going back to the bunker again.